Hi guys, what a nice day to learn something new. So, let's start the new chapter, which is Heron's Formula. You have already studied in your earlier classes about different shapes such as squares, rectangles, triangles and quadrilaterals. You have also calculated areas and perimeters of some of these figures. For instance, you very well know how to find the area and the perimeter of the floor of your classroom, right? Just take a walk around the floor along its sides once. The distance you travelled is its perimeter. So, the perimeter is the length of the outline of a shape. Or in other words, the perimeter of any polygon is the sum of the lengths of all the sides. Further, the size of the floor is its area. That is, area is a measure of how much space is there inside a shape. So, if your classroom is rectangular with length say 10 meters and width 9 meters, then its perimeter would be 2 into 10 plus 9, that is 38 meters, and the area would be 10 into 9, that is 90 square meters. Now suppose that you are sitting in a triangular garden which is in the shape of a right angle triangle with sides 3 kilometers, 4 kilometers and 5 kilometers. So, how would you find its area? Well, from your earlier classes, you know that area of a triangle is calculated using the formula half into base into height. So, when the triangle is right angled, we can directly apply the formula by using two sides containing the right angle as base and height. Like here, we take the base as 4 kilometers and height as 3 kilometers. Then, the area of the triangular park is half into 4 into 3, which is equal to 6 square kilometers. Note that we could also take 3 kilometer as the base and 4 kilometer as height. Now suppose we want to find the area of an equilateral triangle, say PQR, with side 10 kilometers. Now, to find its area using the known formula, we need its height, right? So, can you find the height of this triangle? Can't remember how to do so? Let me tell you. Let us recall how we find the height of an equilateral triangle when we know its sides. Let's say M is the midpoint of the base QR. So, join the midpoint of the base to the opposite vertex, which is P here. So, what do we get by doing this? Well, triangle PMQ and triangle PMR are two right angle triangles. And why? Well, in an equilateral triangle, the bisector of a side is also perpendicular to that side. You can easily prove this by using SSS congruence rule. Now, to find the area of triangle PQR, we just need to find the height PM. For that, apply Pythagoras theorem in triangle PMQ. So, PQ squared is equal to PM squared plus QM squared. We already know that M is the midpoint of base QR. Thus, QM is equal to MR is equal to 5 kilometers. Now we have 10 squared is equal to PM squared plus 5 squared, which on further solving gives PM is equal to 5 root 3 kilometers. Thus, the area of triangle PQR is half into 10 into 5 root 3, which is equal to 25 root 3 square kilometers. Great. Now let's see if we can calculate the area of an isosceles triangle using this formula. Let's take a triangle ABC with two equal sides AB and AC as 5 centimeters each and an equal side BC as 8 centimeters. Here again, we have to find the height of the triangle to find its area. For that, from A, we draw a perpendicular AP to the base BC. You can clearly see that this perpendicular AP divides the base BC in two equal parts. In fact, This is true in general. In an isosceles triangle, the altitude to the unequal side is the perpendicular bisector of that side. Therefore, BP is equal to PC and both are of length 4 centimeters. Now, we apply Pythagoras theorem in triangle ABP. Thus, AB squared is equal to AP squared plus BP squared, which gives AP squared is equal to AB squared minus BP squared. And on substituting the values, we get AP squared is equal to 5 squared minus 4 squared, which on further solving gives 9. This means AP is equal to 3 centimeters. Now, the area of triangle ABC is equal to half into base BC into height AP, which is equal to half into 8 into 3, and we get 12 square centimeters. Thus, we got the required area. Now suppose that we have the length of the sides of a scalene triangle and not the height. So can you still find its area? For instance, suppose you have a huge triangular complex and you only know the length of each side of the complex. Let's say 4 kilometers, 7 kilometers and 9 kilometers. So if I ask you to calculate its area, could you calculate it using the only formula we have for triangles? If we want to use this formula, we need the height of the triangular complex, which we do not have and is very difficult to get using the given sides. So what shall we do now? Will we never be able to find its area? What do you think? Are we the first ones to come across with such a problem? No. Let's go back in history. In 10 AD, a great applied mathematician named Heron was also equally interested to figure out this answer. He tried to replace the value of h in terms of a, b and c so that we do not need the height to find the area of a triangle. He was successful in getting a formula using which we can calculate the area of any triangle, be it isosceles, equilateral, right-angled or scalene triangle. The formula given by Heron about the area of a triangle is also known as Heron's Formula. It is stated as area of a triangle is equal to under root s into s minus a into s minus b into s minus c, where a, b and c are the sides of the triangle and s is the semi-perimeter. That is, s is the half of the perimeter of the triangle. This formula is helpful where it is not possible to find the height of the triangle easily. Now you must be wondering how we got this formula. For that, you have to accompany me in the next video. But before moving anywhere, let's do a quick recap. Area of a triangle is given by the formula half into base into height. This formula can be applied to find the area when the height is known. Area of a triangle with its sides A, B and C is calculated using Heron's formula, stated as area of a triangle is equal to under root s into s minus a into s minus b into s minus c, where s is the semi-perimeter, that is, half of the perimeter of the triangle.